back again with another video. So now, as you can simply see here, that we have three problems. So the first problem, we just need to solve for x. We are given x to the exponent of x is simply equals to 4, which is just simple. Then now looking at number 2, we have x is equals to 1 over 2 plus 1 over 2 plus 1 over 2 plus keeps on going to positive infinity. Then we just need to find the sum. So now x here is equals to 1 over 1 plus 1 over 1 plus 1 over x. So here we just need to solve for x again. Now, looking at this one, it's a bit of a problem, but think of it in this manner. It's just x is equal to 1 plus 1. We need to find the answer here. So the answer here is just going to be x equals to 2. Why? It's simple because we're adding these two. So we want to find the sum of this, but just that it's continuous. So I'm just going to go deep with number 2 once I get to number 2. But now, let's start with x to the exponent of x is simply equals to 4. Then we just need to solve for x. Now, in order for us to solve for x, we look at this side. It's simply x to the exponent of x. So now, left-hand side, in order for us to be able to solve this, it must be equal to right-hand side. So now, looking at x to the exponent of x is equal to 4, we can simply see that this is more like something in the form of the very same base raised to the very same exponent as that base. So now x to the exponent of x, we think of 4. How can we make 4 the very same thing as x to the exponent of x? And we know very well that the prime factors of 4, it can only be 2 to the exponent of 2. So now if we can simply write here 2 to the exponent of 2, we can see that now left hand side is simply equals to the right hand side. Now once we prove that the left hand side is equals to the right hand side, then we know very well that if the x is the base name, 2 is the base, and now x here is the exponent, and this 2 is the exponent. So now our x, we can simply say it's simply equals to 2. Then we are just done with the first one. So I'm just gonna erase this, then I come to number 2. So now let's see. Let's look at number 2 now. Number 2, that is when now we are looking for the sum. So when we are looking for the sum, we have x is equal to 1 over 2 plus 1 over 2. Now let me write this first. So we have x, which is simply equals to 1 over 2 plus 1 over 2 plus 1 over 2 plus. So this goes on to positive infinity. Now let's think about something. There's something that, if you can watch the previous video, you will see that we had x is equals to the square root of 6 plus the square root of 6 plus the square root of 6. So we ended up thinking that, okay, fine, we know very well that our first x is simply the square root of 6, right? So we ended up having x is equals to the square root of 6 plus x. So that is what we did. So this is the very same thing as now. If we can look at what is it that is being added, then we just say x is just gonna be equals to 1 over 2. Can you see that 1 here is always there, and this 1, then this 1 here is always there. So we always have these two. So we can just write this. But now in the space of that, now we keep on getting something that is being added. So we replace that with x. That's simple. Then now we know that x is going to be equals to 1. Then we cross multiply. When we cross multiply, we're just going to get x into 2 plus x, which is equals to 1. Why? Simply because 1 times 1 is simply 1. Then x multiplied by this is simply x into 2 plus x. So how can we remove the bracket? We simply multiply this and multiply this again. So we're just going to get 2x plus x squared, which is equals to 1. Now let's continue this side now. So we have 2x squared plus x squared, which is equals to 1. Now let's continue here. This here, it's just going to be x squared plus 2x minus 1, which is equals to 0. Now thinking of this, it's just a trinomial, right? It's a quadratic. So while we have this quadratic, we cannot factorize x squared plus 2x minus 1 in terms of opening two brackets or taking out a common factor. Instead, what we can do here, we are using the quadratic. But we're just going to continue here on the second one. Okay guys, back again. Let's just continue where we left off. So we have x squared plus 2x minus 1 equals to 0. As I said, here we cannot get the factors that can give us 2, right? At the same time, there's nothing that is common within these terms. So let's look at it. The third method that we can use here is simply the quadratic method. But now let's think about it. In order for us to use the quadratic method, we must know the standard equation of the quadratic. Now, the standard equation is simply ax squared plus bx plus c. And now we know that the quadratic is going to be x is equals to negative b plus minus square root of b squared minus 4ac over 2a. Now, in the space of a here we have coefficient of x squared, which is 1 there. In the space of b, we have 2. In the space of c, we have negative 1. Now let's look at it. We have these values. A is equals to 1, b is equals to 2, then c is equals to negative 1. Now let's check here. Negative b, we know that it's 2. We put our 2 there, plus or minus square root of. Now here it's b. We put 2 again, squared minus 4 into our a is 1, then our c is minus 1. Let's extend that over 2 into we put 1. Now, this now is going to be negative 2 plus or minus the square root of 4 minus, let's just say 4 plus, we're just going to say 4 plus 4, right? Yeah, we're just going to say 4 plus 4 over 2. So this is simply going to be negative 2 plus minus the square root of 8 over 2. Understand? So now this is just going to be our answer. Let's not simplify it further that much. So we have x there as negative 2 plus minus square root of 8 over 2. So the first x is simply going to be negative 2 plus square root of 8 over 2, or x is equals to negative 2 minus square root of 8 over 2. Now let's think of this now. Going back there, if we have negative 2 plus root 8 over 2, or we have x is equals to negative 2 minus root 8 over 2. Then if we go back and put here, you can see here somewhere around about this one. So if we put the negative value or this positive value, yeah, just this, the difference only. So now we've got our values of x. Then now the sum is simply going to be our x as negative 2 plus over 8 over 2. Understand? So that is where now we know that our sum is just going to be equal to this. If it keeps on going, the sum is just going to be equal to this. Why? Simply because, why are we saying it's going to be this? We are choosing the one with positive value. Why? Simply because you can see that it keeps on adding. Understand? We're not decreasing, but we're increasing. Understand? Positive infinity. Now looking at this, it's just a negative. So we cannot have that negative minus root 8 over 2. So this is what we're going to have. So we are done from here. Then we're just going to move to the last one now. Let's just go back this side. So we are doing the last one now. The last one can give us a bit of a problem if we do not understand number 2. But since now we understand number 2, let's just check what is it that we're going to get. Now we have x. We have x is equal to 1 over 1 plus 1 over 1 plus 1 over x. So x is simply equals to 1 over 1 plus 1 over 1 plus 1 over x. We need to solve for x here. Now, solving for x here, we simply can see that this is our denominator. Then here there is another denominator. The first thing we can do, multiply it by the denominator both sides, or we cross multiply. That's how we call that. So now we're just going to multiply, cross multiply. So we're going to have x into, let me use a different color. Yeah, we're just gonna have x into 1 plus 1 over 1 plus 1 over x, which is equal to that 1 times 1. So now we remember we need to multiply this and this, multiply this and this. So now we're going to get x plus x over 1 plus 1 over x. Right? So x times x is x. Plus x times this is x over 1 plus 1 over x, which is equals to 1. Let's continue. We're going to continue this side now. Okay. Now we have that. So simply we have x is equals to we have x plus x over 1 plus 1 over x, which is equals to 1. Let's continue. From here, how do we remove that denominator, which is 1 plus 1 over x? We can remove this denominator by multiplying by the very same denominator in every term that we have within this equation. So now we have x here, this x, we can multiply it by 1 plus 1 over x, plus x, we multiply it by 1 plus 1 over x, over 1 plus 1 over x. Let's put bracket here, which is equals to this 1 multiplied by 1 plus 1 over x. So these two brackets now, they cancel out. Then we are left with that. But that we can simply multiply it for it. So we're going to have x plus x over x, which is 1. Then plus these two cancel, we're left with x, which is equals to 1 plus 1 over x. Now look at it. We have x plus x, which is 2x plus 1, which is equals to 1 plus 1 over x. Can you see that? Let's just finish fast. So we are multiplying by the denominator everywhere so that we remove this. So we're going to multiply 2x by x, we get 2x squared plus 1 times x is x, which is equal to 1 times x, x again, plus 1 x over x, it's just going to be 1. Now 2x squared plus x minus x equals to, minus 1 equals to 0. Then these two are additive inverse, we cancel them out. We're left with 2x squared minus 1, which is equal to 0. Then 2x squared is equal to 1. Then divide both sides by 2. Then we are left with x squared is equal to 1 over 2. Now we need to square both sides in order for us to solve x. So when we square here and we square here, we simply get x as 1 over 2 raised to an exponent of 1 over 2. It's going to be 0,707. Since it's 1 over 2 raised to 1 over 2. So that's just our answer, guys. So we know very well that one number 3, our answer, it's just going to be 0,707. Thank you, guys. I'm just going to see you on my next video. Ciao.